We're diving straight into the most extreme, mind-bending objects in the universe. We aren't just talking about places where the grand stage of space and time is warped. We're talking about places where it is completely, fundamentally broken. Throughout this journey, we are going to unpack the terrifying yet absolutely thrilling reality of black holes.
So, we all know black holes are these cosmic trapdoors with insanely intense gravity. But what would it actually feel like to take a hypothetical, one-way descent right into the center? It's a question that really pushes the boundaries of our imagination, not to mention our physics. We've all heard the warnings to stay far, far away, so today we are going to do the exact opposite. We're going to jump right in.
Okay, first, let's establish exactly what we're dealing with here. A black hole isn't just some empty void. It's a region in space where the force of gravity is so incomprehensibly strong that absolutely nothing can get away. Not even light, which is literally the fastest known entity in our entire universe. These are spots where incredibly dense matter bends the very fabric of space and time to its absolute breaking point.
So how do these monsters actually come to be? Well, it all starts with a massive dying star. For its whole life, this star is holding itself up against its own immense weight. But when it finally runs out of fuel, gravity wins. So the core violently implodes in mere milliseconds, collapsing at nearly a quarter of the speed of light. Before the star even registers what's happening, it detonates in a tremendous supernova, unleashing more energy than our sun will produce in its entire lifetime. And what's left behind? That inescapable trapdoor.
To really wrap our heads around the extreme density we're talking about, imagine taking a massive star, let's say 10 times the mass of our very own sun, and you just crush all of that matter down. The resulting sphere would be a mere 60 kilometers across. That is an unimaginable amount of matter packed into a space roughly the size of a city. It's just wild.
Now, the sheer scale of the danger out there is just staggering. On one hand, you have your stellar black holes, right? These are about 10 to 20 times the mass of our sun, and there could be millions of these scattered just throughout our Milky Way alone. But then you have the absolute giants, the supermassive black holes. These behemoths are millions or even billions of times more massive than our sun. They lurk at the center of pretty much every large galaxy out there. So, for instance, you've got Sagittarius A right in our galactic backyard, weighing as much as 4 million suns.
All right, let's start our descent. As you get closer, you'd encounter what's basically the strangest funhouse mirror in the universe. Hovering just outside the boundary, in a region called the photon sphere, gravity is so incredibly intense that light itself actually orbits the black hole. Because that light is trapped traveling in circles, looking straight forward means the light from your own back travels entirely around the black hole and right into your eyes. You would literally be staring at the back of your own head. And trust me, it gets weirder. Because gravity severely alters the passage of time itself. As you descend, the stronger the gravity gets, the slower your time passes. Your clock slows down to an absolute crawl. But if you were to look up, you'd watch the rest of the universe play out in fast forward. So, you are essentially taking a terrifying, one-way time travel trip to the future. If you somehow manage to fly away at this point, you'd find that eons have passed, and everyone you knew is long, long gone. So now we hit the crucial point of our journey, crossing the event horizon. This is the boundary of the black hole, the absolute point of no return. It forms a shell around a region of space where the escape speed finally equals the speed of light. And since not even light can escape to transfer information to the outside, we truly cannot see what it looks like inside. Once you cross this line, you are shielded from the rest of the universe forever. Now here's a detail you'll want to remember. Your choice of black hole really matters. You see, you might actually survive crossing the event horizon of a supermassive giant because the gravitational gradient is much more gradual. But if you get too close to a smaller stellar black hole, well, you face a highly agonizing physics-driven death long before you even reach the threshold.
Scientists literally call this spaghettification. It sounds kind of funny, but the reality is incredibly gruesome.